Welcome to Statistics. My name is Melissa Whitmer, and in this lesson, we will look at statistical and critical thinking. The process involved in conducting a statistical study consists of prepare, analyze, and conclude. Statistical thinking involves critical thinking and the ability to make sense of results. Statistical thinking demands so much more than the ability to execute complicated calculations. Here we'll examine some data that's represented in a bar graph. Is YouTube becoming a more important learning tool? A recent Pearson survey conducted by the Harris Poll examined how technology has shaped students' learning habits and compared the responses from Gen Z, ages 14 to 23, and millennials, ages 24 to 40. Among other topics, this survey asked respondents to identify their preferred learning tools, and YouTube was identified as one of the top tools by both groups. Examine this graph that depicts the percentage of Gen Z and millennials who identified YouTube as the preferred learning tool. Use critical thinking to analyze the graph. So when we analyze a graph, we want to look first at the comparisons of the data shown by the heights of the bars. So the Gen Z had a preference between 58% and 60%, so that might be close to 59%. The millennials had a percent between 54 and 56, so the comparison is 55% of millennials compared to about 59% of Gen Z who preferred YouTube. The same data are shown in this graph below. Can you identify what changed? And why is this a better graph to depict the data fairly? So visually, we can see that now the heights of the bars aren't so far apart. However, if we look at the actual height of the bars, their totals have not changed. So what changed? Well, the y-axis is now starting at 0% and it's going up by increments of 10%. On the previous graph, the y-axis started at 52% and went up in increments of 2% up to 60. So one thing that we want to look out for is misleading graphs. The bar chart in the first figure is very deceptive. By using a vertical scale that does not start at 0, the difference between the two percentages is grossly exaggerated. We will discuss deceptive graphs later in section 2.3. Another flaw to look out for is a bad sampling method. Now in this study, both figures are based on data from the Pearson survey cited earlier. This study included 2,587 respondents from a nationally representative sample, and the sampling method appears to be sound based on the description provided in that report. However, many other surveys obtain participants by using methods that are inappropriate and may lead to biased results, such as these. A voluntary response sample. Here, participants decide themselves whether to participate. For example, a survey question is posted on a website, and then internet users decide whether to respond. With a voluntary response sample, it often happens that those with a strong interest in the topic are more likely to participate, so the results are very questionable. A convenience sample is another one to look out for. Here, participants are selected because they are easy to reach and are readily available. For example, a student conducts a survey of fellow students relaxing in a cafeteria. Now let's cover some broad definitions related to this course. Data are collections of observations such as measurements, genders, or survey responses. And statistics is the science of planning studies and experiments obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. Believe it or not, we will cover all of these topics in this entire course. A population is the complete collection of all measurements or data that are being considered. Typically, a population is the complete collection of data that we would like to make inferences about. A census is a collection of data from every member of the population, and a sample is a sub-collection of members selected from a population. Let's explore a scenario now where we have to determine what the population and sample are. In a survey of 410 human resource professionals, 148 of them said that job candidates were disqualified because of information found on social media postings, based on data from the Society for Human Resource Management. Can you identify the population, which is all people that we might want to get information about? And then can you identify the sample that's representative of that population? In this case, the population and sample are as follows. The population would be all human resource professionals. Since we cannot get information and survey every single human resource professional, we have a sample. The sample is the 410 human resource professionals who were surveyed. So the objective in statistics is to use the sample as a basis for drawing a conclusion about the population of all human resource professionals. And methods of statistics are helpful in drawing such conclusions. Here we have a flow chart that describes our process for statistical and critical thinking. First, we prepare. We look at context, the source of the data, and the sampling method. Under context, we ask, what do the data represent, and what is the goal of the study? When we look at the source of the data, we want to explore whether the data is from a source that might have a special interest, so there's pressure to obtain results that are favorable to the source. And then with the sampling method, it's important to look at how the data was collected. Is it unbiased or is it biased, like in a procedure where respondents volunteer to participate? Now we analyze. Here we can graph the data, explore the data, and apply statistical methods. When we explore the data, we look for things like outliers, which are numbers very far away from almost all the other data. And we look at important statistics to summarize the data, like the mean and the standard deviation that we'll learn about in Chapter 3. Some other questions are, how are the data distributed? Are there missing data? And did any or many selected subjects refuse to respond? Then we use technology to apply statistical methods to get results. Finally, when we conclude, we look at significance. Do the results have statistical significance? And do the results have practical significance? Next, we're going to look at a data set, and we're going to use some critical thinking to examine the context, the source, and the sampling method. Here we have a table showing various shoe print lengths and heights of 8 males. So these are matched data to a person. For the context, what do you think the data represent? And can you identify why this data may be useful to know for certain professions? That's where the critical thinking comes in. You might have to really think about how this data could be important. Finally, what is the goal of this study? Do you think there's a hypothesis that we can form based on the data? Well, it's very obvious that this table includes shoe print lengths and heights of 8 males. So forensic scientists measure shoe print lengths at burglary scenes and other crime scenes in order to estimate the height of the criminal. The format of the table suggests a goal. Determine if there is a relationship between shoe print lengths and heights of males. This goal suggests a reasonable hypothesis. Males with larger shoe print lengths tend to be taller. We are using data for males only because 84% of burglaries are committed by males. Now let's look at the source and the sampling method. The source of the data in the table come from Dataset 9, Foot and Height in Appendix B. Here the source is identified and the source appears to be reputable. In that source, we are also told that the individuals were randomly selected, so the sampling method appears to be sound as opposed to being voluntary. So just as a reminder, a voluntary response sample or self-selected survey sample is one in which the respondents themselves decide whether to be included. The following types of polls are common examples of voluntary response samples. By their very nature, all are seriously flawed because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. Internet polls, mail-in polls, and telephone call-in polls are all examples of where people decide whether to respond. In our next scenario, we're going to compare two different sampling methods and see which one will give a better result. The ABC television show Nightline asked viewers to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that the United Nations should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the United Nations to move out. First off, the two polls produced dramatically different results. Even though the Nightline poll involved a large sample of 186,000 volunteer respondents, the much smaller poll of 500 randomly selected respondents, that's more likely to provide better results that matches the whole population of Americans. That's a better sampling method. When we analyze data, we need to consider the graphing and how to explore the data, and then how to apply statistical methods. Remember, a good statistical analysis does not require strong computational skills. It does require common sense and paying careful attention to sound statistical methods. With our conclusion of a statistical study, we have to develop an ability to distinguish between statistical significance and practical significance. Statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So we actually have a numerical measure that we use to achieve statistical significance. So when we look at getting a boy or a girl with a birth, those are equally likely events, and there's a 50% chance of having a boy and a 50% chance of having a girl. So if we have a study showing that they got 98 girls in 100 random births, that would be statistically significant because such an extreme outcome is not likely to result from random chance. Getting 52 girls in 100 births is not statistically significant. That's about half of the births, and that event could easily occur with random chance. It is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. Let's look at a real study that was conducted, and this will show the difference between statistical and practical significance. In a trial of weight loss programs, 21 subjects on the Atkins program lost an average, or mean, of 2.1 kilograms. This is about 4.6 pounds. This was after 1 year. The results show in this study that this weight loss, it is statistically significant. So they were able to report these results and say that the Atkins program created statistically significant weight loss. That just means that the weight loss was not likely to just happen by chance. However, many dieters believe that after following the diet for a year, a loss of only 2.1 kilograms is not worth the time, the cost, and the effort. So for these people, this diet does not have practical significance. Next, we're going to explore some potential pitfalls in statistical studies. So we want to watch out for all of these because they can create bias or skew the results. Misleading conclusions. So when forming a conclusion based on statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. Sample data, if it's reported instead of measured. So when we collect data from people, it's better to take measurements yourself instead of asking the subjects to report the results. Loaded questions are commonly used on ballots. If survey results are not worded carefully, the results of a study can be misleading. Also, the order of questions can impact the results. Sometimes survey questions are unintentionally loaded by the order of the items being considered. We also want to look for a non-response. This occurs when someone refuses to respond or is unavailable. So when surveys are sent out, we want to look at the response rate and see if there's a large non-response rate. Low response rates occur and they can affect the reliability of the results. So in addition to having a smaller sample size, there's an increased likelihood of having a bias among those who do respond. And finally, percentages. Look very carefully at the way studies cite possible misleading percentages. Note that 100% of some quantity is all of it, but if there are references made to percentages that exceed 100%, those references are often not justified. Let's see if you can identify the flaw in this study. In a survey of 621 subjects, the following question was posted on a newspaper's website. In your view, are nuclear plants safe? The survey subjects were internet users who chose to respond to the question posted on the electronic edition of the newspaper. So the key phrase here is they chose to respond and it was posted online. So the flaw here is it is a voluntary response sample. Several studies showed that after eating a very large meal, subjects had increased risk of heart attack. A diet food manufacturer financed this research. So what is wrong with this? Well, that second sentence right there gives it away. It is questionable that the sponsor is a diet food manufacturer because this sponsor can be greatly affected by the conclusion. Which of the following would be considered practically significant? An average of 1.2 pounds was lost over a 12-month period using a new diet program. Is that practical? 1 out of 50 people were not smoking 12 months after completing a non-smoking program. Is that practical? 8 out of 14 births resulted in male children. In a very large study, it was found that treatment 1 resulted in 93% success and treatment 2 resulted in 75% success. So which of these is going to have some practical results? Option D would. Here we have a large study and we have very high percentages of success rates. So it's highly unlikely that this occurred by random chance, and it's also such a large success rate that it would most likely have practical significance.